In this section, we will implement sliding obstacles to challenge the player's movement and timing. These obstacles will require the player to perform a sliding action to pass underneath, adding variety and increasing the complexity of the gameplay. We begin by making a small adjustment to organize our scene. In the scene hierarchy, right-click and create a new empty game object. Reset its transform and rename it to Road Barriers. Then, select all the Road Barrier game objects in the scene and make them children of the Road Barriers game object. Next, navigate to the City Props Bundle folder and open the Prefab subfolder. Locate the prefab named Road_Barrier_02 and double-click to open it. In the inspector, resize the prefab by setting its x-axis to 1.5 and y-axis to 1.3. Add a mesh collider component to the prefab, then add a Rigidbody component. Set the Rigidbody to is kinematic and enable freeze position and freeze rotation to prevent unintended movement. Create a new tag named Obstacle and assign this tag to the prefab to designate it as the sliding obstacle. Save the prefab, return to the Unity scene, and drag and drop the Road_Barrier_02 prefab into the scene. Position it at x equals 1 and z equals 10, placing it directly in front of the player. Next, we will set up the colliders for our character. Select the AJ game object from the scene hierarchy, expand the hips tree, and locate the child game object named left toe base. Add a box collider to this game object and adjust its size to 0.1, 0.25, and 0.1 for the X, Y, and Z axes, respectively. Set the center of the box collider to 0, -0.05, and 0.05 for the X, Y, and Z axes. Enable the is trigger checkbox and copy the component settings. Next, navigate to the right toe base game object in the scene hierarchy and add a box collider. Paste the copied values into this component. Afterwards, locate the backpack game object under Spine 2 in the AJ hierarchy. Add a box collider to the backpack game object and set its size to 0.4, 0.5, and 0.4 for the X, Y, and Z axes. Adjust the center to 0, 0, and -0.3 for the X, Y, and Z axes. Enable is trigger checkbox. Now go to the Scripts folder, right-click, and create a new script named BodyCollision. Open it in Visual Studio. Copy the code from the PlayerController class, as the functionality will be similar. Remove the start and update methods, and change the PlayerController and animator references from private to public. In the onTriggerEnter method, replace the input string parameter from barrier to obstacle in the compareTag function. Update the debug log message to refer to obstacle instead of barrier. Next, open the PlayerController script and add a new public Boolean variable called isPlayerAlive, initializing it to true. In the dead method, before calling the invoke function, set isPlayerAlive to false. Return to the BodyCollision class and modify the collision logic by adding a condition to check PlayerController.isPlayerAlive alongside the compareTag method. This ensures collisions are not processed multiple times after the player dies. Apply the same change in the BarrierCollision class to maintain consistency. At the beginning of the start method in the PlayerController script, set time.timescale to timescale, a public variable initialized to 1.0, allowing us to test collisions in slow motion. In the Unity editor, adjust the scene view to focus directly on the obstacle. Then, select the Backpack Child game object in AJ and attach the BodyCollision script. Drag and drop the AJ game object into the animator and PlayerController fields of the BodyCollision component. Add an audio source component to the AJ game object. Assign it to the audio source field of the BodyCollision component, and set the Pane 5 audio clip from the audio folder to the Clip Collide field. Click play and let the player collide with the obstacle to test the fall animation and scene restart functionality. After the game restarts, test sliding under the obstacle. If you fail, try again. You can also adjust the timescale value in the PlayerController component to 0.2 through the inspector to observe the sliding in slow motion. This concludes our section on implementing sliding obstacles. In the next section, we will focus on implementing jump obstacles.